So in this lesson, what we're going to look at is now that we have compounds, we are going to see what is the percentage of the compound that is a specific atom. And so, for instance, if I want to know how much of something out of the whole am I looking for? So that's what a percentage is. It's the part out of the whole, and we're going to multiply by 100. So you've probably seen percentage before in math class. So here's just a great thing, okay? So it's the percent of each element present in a compound. Okay, you have to determine how much of each element is there. So a way to think about it is if I have a water bottle, okay, how much of the whole mass of that bottle is just water, not including the plastic that makes up the water bottle or whatever. So it's the same concept. We're seeing the part divided by the whole. Okay. Right. So percent composition, you need to figure out your chemical formula first. Okay, so in our example in our notebook, it is NaCl. You're looking for the percent of each element. Okay, so the percentage of sodium and the percentage of chlorine. Okay, so to find each element, we are going to do a couple steps. So first step is we need to determine the mass of each element from our periodic table. Then we need to find the molar mass of that specific compound. Then we're going to determine the percentage. So we're going to take the mass of the compound, we're going to take the mass of the element and divide it by the mass of the whole compound, and then multiply by 100. So we need the mass of the whole compound. So again, I'm using sodium chloride. So sodium is again 23.0, chlorine is 35.5, and my total mass is 58.5. So to solve for sodium, I'm going to take 23.0 grams. I'm going to divide it by 58.5, and I'm going to multiply that by 100%, okay, or 100. You have to do percent sign, don't do percent sign. So 23.0 divided by 58.5 gives me 39.3%. Okay, to do chlorine, I'm going to take 35.5 grams. So that's the part. That's the biggest thing. You understand, you're looking at the part. Okay, 35.5 grams. Again, divided by my whole, which is 58.5, and multiplied by 100. So 35.5 divided by 58.5 gives me 60.7. Okay, 60.7. So 39.3 and 60.7 will add up to 100%. That's your way of checking. Okay. Now sometimes you might go, well, Miss B, I got 99.9%. That's okay, because remember, rounding sometimes throws you off, but you should be as close to 100%, if not 100% every time. Okay, so let's take a look at another one. So, oh, so we're actually not going to look at that one. So if we looked at water, okay, you would take, if we did water, we would do 2 divided by 18 and 16 divided by 18, okay? So that's what we're looking for. Then the reason I say 2 and not 1 is because there's 2 hydrogen that we have to account for. Okay, so we're looking at the total mass of that particular element. So in that case, subscripts are important. And we're going to see that in a second. Okay, there's a specific percent that's important, and that's the percent hydrate. And so when you think of the word hydrate, I'm hoping the word water comes. They tell you to hydrate often. So a hydrate is a compound that has water in it. It's usually a crystal. And we use these a lot in chemistry. They're in some of our chemicals. Um, so we'll say some things like a trihydrate or a pentahydrate. It means it has 5 molecules of water in it as we're building, or 3, or however many it says. Anhydrous or an anhydrate is when I go ahead and I take the water out. So I heat it up, or evaporation occurs, the water in the compound is removed through heating and it becomes a powder. And a great example of this is if you remember back to um, the physical and chemical change lab that you watch when we put solutions together, made precipitates, There's one where we put blue powder into a test tube, and then we heated it up, and then it turned white. That is because that chemical was copper sulfate pentahydrate, and when we heated it, the water evaporated out and it turns white. So that made it an anhydrate. So the percent hydrate is, instead of looking for the percent of a specific element in the whole piece, we're looking at how much water is in a compound. So we're going to look at the hydrate, beryllium nitrate trihydrate. Okay, now um, remembering our prefixes from naming covalent compounds. We know that tri means 3, and if you notice, there's 3 waters. That's why it's a trihydrate. Okay, so steps, I need to find the molar mass of my compound, and that includes the water. So we have to include the water in everything. So then we're going to do molar mass of water, which we have done in the past. And it's going to be one of those things that you do it so much, you're going to kind of know it. But we're going to take a look at it. And then we're going to add the mass of the compound and the mass of the water, and we're going to determine the percent of the water. The mass of the water divided by the total mass of the compound and multiply by 100. Just like we did with our percent composition, we're just going to take it a step further and just do the water this time. So here's my example. So BeNO32 is 133.32 grams. Okay, beryllium is 9.012 grams. Nitrogen is 14.01, but there's 2 of them. And the reason there's 2 is you have a 2 out here on this as a subscript that gets distributed out. Oxygen is 16, and of course we have 6 because we have our 3 inside, and we're going to distribute our 2 to make it 6. So that's 96. So when you add all those together, you get part of this, and then we have to do our water. And so water, again, is 18, in this case 18.02. The person who made these slides, they don't do the 1 number after the decimal point. They do a little bit further. But we also have 3 of them. That's what that tri means. So 3 times 18 gives me 54.6. And we're going to add all of these numbers, 9.012, 28.02, 96.003. All that stuff gets added to 133, or becomes 133, and our 54. So we're going to add 54 and the 133 together. Okay. I get 187.092 grams. So the entire mass of beryllium nitrate trihydrate is 187.092. Okay. We are then going to take our water, which is 54.06. We're going to divide it by our 187.92 and multiply it by 100, and you get 28.89%. So the water is almost 29% of the weight of this particular compound. So that's percent composition, percent hydrate. Percent composition, we're looking at the part, okay, the specific element out of the whole compound and seeing what percentage that is. A percent hydrate is doing the same thing, except for the specific part we're looking at is the fact that it has water in this compound. And so we're looking at the water out of the whole compound and going there.